For over 400 years, humanity has stared at Jupiter's Great Red Spot, believing it to be a permanent, unchanging monument of our solar system. But when astronomers recently turned the Hubble Space Telescope and the Juno spacecraft toward the gas giant, they realized we have been dead wrong. Jupiter is not the stable, predictable planet we thought it was. Its most famous feature, a swirling anti-cyclonic storm larger than Earth, is hiding terrifying secrets deep beneath its clouds. And even more frightening, the greatest storm in the solar system is currently dying, and in a desperate fight for survival, it has begun to cannibalize other storms. The flight into Jupiter's atmosphere is a descent into a bottomless nightmare. Unlike Earth, Jupiter has no solid surface to cause friction and break up weather systems. It is a massive, endless ocean of gas, meaning a storm can rage for centuries without ever hitting land. And absolutely nothing embodies this endless violence like the Great Red Spot. Historically, observations of a giant spot date as far back as Robert Hooke and Giovanni Cassini in the 1660s, though modern scientists now believe that original storm may have disappeared, making the current red spot an entirely new monster that formed sometime before 1831. Regardless of its true age, this storm is an absolute behemoth. It rotates counterclockwise, violently confined by a modest eastward jet stream to its south and an extremely strong westward jet stream to its north. The winds around the jagged edges of this terrifying vortex peak at an astonishing 496 kilometers per hour. But the sheer speed of the winds is nothing compared to the true scale of the beast. For decades, we only saw the flat, two-dimensional top of the storm. When NASA's Juno spacecraft conducted a daring pass directly over the spot in 2017, taking microwave radiometer scans from just 8,000 kilometers above the clouds, it revealed the terrifying truth. The Great Red Spot is not just a surface weather event. It is a three-dimensional monster whose roots plunge deep into the dark, crushing mantle of Jupiter. The storm's vertical depth extends far below the visible cloud layer, reaching up to 500 kilometers down into the planet's abyss. Down there, the atmospheric pressure drops to a crushing 100 bar, and a dense, massive gravitational anomaly anchors the storm. It is a vortex so unfathomably deep that it taps into jet streams well below the visible structure's base. But while the absolute depths of the storm remain freezing cold and shrouded in thick phosphine and ammonia aerosols, the environment directly above it is a chaotic inferno. Infrared data has definitively proven that the core of the Great Red Spot is colder than the surrounding clouds. Yet, the upper atmosphere, directly above the storm, is inexplicably hot, reaching face-melting temperatures of 1,330 degrees Celsius. That makes it hundreds of degrees hotter than any other location on the planet at that altitude. How is this possible? Scientists discovered that the extreme violent turbulence of the storm below generates massive acoustic waves. These brutal waves of pure sound energy travel 800 kilometers vertically into the upper atmosphere, where they violently break and convert their wave energy into extreme heat. Researchers literally compare this phenomenon to massive ocean waves crashing brutally onto a beach. The Great Red Spot is screaming into the upper atmosphere, setting the sky above it on invisible fire. You might think a storm this massive, this deep, and this violent is invincible. But the latest images from Hubble reveal a chilling reality. The Great Red Spot is shrinking at a terrifying rate. In the late 1800s, historic observations gauged the long axis of the storm to be an incredible 25,500 miles wide. When NASA's Voyager 1 and Voyager 2 space probes flew past Jupiter in 1979, the storm had already violently contracted to 14,500 miles across. By 2014, Hubble confirmed it had shrunk down to just 10,250 miles. The storm's waistline is vanishing by 580 miles every single year, and its shape is aggressively morphing from an elongated oval into a perfect circle. In 2019, astronomers even witnessed the spot actively flaking at its edges, with massive, swirling fragments of the storm spinning off and dissipating out into the dark Jovian atmosphere. To survive this total collapse, the Great Red Spot has turned to cannibalism. Using complex 3D simulations known as the Explicit Planetary Isentropic Coordinate Model, researchers uncovered the storm's dark secret. The Great Red Spot is sustaining itself on a strict diet of smaller Jovian storms. High-pressure eddies, anti-cyclones, and completely separate weather systems are being dragged into the massive vortex and swallowed whole. These aggressive interactions alter the internal dynamics and energy of the Great Red Spot, acting exactly like atmospheric heat domes on Earth that trap and amplify extreme weather events. Its legendary red-orange color, which is likely created by solar ultraviolet irradiation, baking ammonium hydrosulfide and acetylene into complex organic compounds called tholins, varies wildly from brick red to pale salmon as it shrinks. But while the old king slowly dies, a new threat is already rising. In the year 2000, 3 white ovals merged in the southern hemisphere to form a brand new storm called Oval BA. Just 6 years later, that new storm turned a deep blood red. Jupiter is already breeding the next monster. The Great Red Spot is not an eternal, peaceful feature of our solar system. We are simply lucky enough to exist in the exact, tiny window of time to witness it. If this collapse continues, this centuries-old monster could become perfectly circular by 2040, or dissipate entirely within a few decades, leaving behind a fundamentally changed Jupiter. The king of the planets is actively destroying its own crown jewel, proving to us once and for all that in the violent extremes of deep space, absolutely nothing lasts forever.